Hi, everybody. This is Amy from Nexcelent Bioscience, and I'd like to thank all of our attendees for joining us today for our Celigo user training webinar. The topic today will be an apoptosis assay on the Celigo imaging cytometer, specifically with the Annexin 5 PI Hoechst reagent, and it will be presented today by Sarah Kessel, who is our application scientist and lab manager at our San Diego office. Just a reminder to all of our attendees that you will be muted throughout the duration of the webinar, but if any of our attendees have any questions for us, feel free to type them into the questions bar, and we will have time at the end to answer any questions you guys have. Also, the session today will be recorded, so everyone who is registered for this webinar will receive a link via email to the recording, and they can watch this webinar over again, or you can pass it along to a friend or colleague if you wish to share this content with them. Okay, so I'm going to pass it over to Sarah Kessel to begin our presentation today.
Thanks, Amy. Hi, everyone. Welcome. I'm really excited about today's webinar because this reagent has been around forever, but it's typically run on a flow assay where you have to trypsinize your cells out of the plate, and it's just complicated. You lose cells and so forth. So if you tried the image-based version on some of these vendors that are supplying it, you have to do some washing. So what I've done is I've taken some of the reagents from the available in the market, and I've tweaked the recipe a little bit so you don't have to do any washing. So I'm excited to show you this assay. So today we're going to give you a little bit of overview on the Annexin 5 assay. Then I'm going to show you the plate design and setup that I'm using to showcase a time course drug treatment, which the time for the Annexin 5 or the apoptosis to happen is pretty quick. So I wanted to show you that. And then how to acquire the images and analyze them. And then we'll go over the data and show you the results in the graphs. Okay, so the Annexin 5 assay. Here you have a picture from the BioLegend website for this healthy cell versus apoptotic cell. What this assay does is it's actually detecting phosphatidylserine, which is a molecule that's normally found on the inside of the membrane of the cells. When you have a cell that's actually triggered to go through apoptosis, that phosphatidylserine, we're calling it PS here, is actually going to be translocated to the external portion of the cell, exposing it to other markers looking for things. So when you have a calcium-rich environment, so when we add the binding buffer for this assay, which has a lot of calcium in it, the Annexin 5 has a high affinity to bind to the PS externalization molecule. Now, if that annexin is actually tagged with a fluorophore, and today we're using FITC, then you can actually identify the cells that are going through apoptosis and having that phosphatidylserine exposed to the external part of the cell. So this is typically an early occurrence for the apoptosis. When the membrane becomes leaky, that's when propidium iodide, which is the other dye that we'll be using, tends to penetrate through the cells and bind to the DNA. So we'll be able to identify those dead cells as well. And we're going to use Hoechst to identify all the cells. It will bind through the membrane and go to the DNA and bind and tell you which ones are live or dead. So from this, we'll be able to give you a total count, the early apoptotic cells, the Annexin 5 and PI labeled cells, which are later apoptotic cells, as well as if there was only a necrosis effect going on, then we would have the PI only population. So those were the dyes that we're going to use and the populations that we're going to identify in today's assay. So on the right, I have the plate map layout that you're going to see today in our experiment, as well as the time course that I'm going to be adding the drug treatment. So you'll see that I'm doing it in replicates on a 96-well plate. So on day 0, I'm plating the cells in a 96-well plate. Typically for this cell line, which is the MDA 231 cells, it'll be about 10,000 to 12,000 cells per well in 100 microliters. The next day, I'll prepare a 2x concentration of the drug with this dose response as you've seen in the map. And then I'll be adding drugs selectively on certain hours. So columns 3, 4 will be early in the morning, and then every hour I'm adding more drug to the next 2 columns over. At the end, I'm going to be adding the Annexin 5 PI in Hoechst concentration that I've worked with. Each vendor has different concentrations, so just be careful if you're going to try this. You should probably titrate it out to figure out what's going to give you signal without background. So here's the critical part for the no washing. I'm removing 150 and leaving 50 microliters in the well. And then I'm coming in with 100 microliters of my dye solution mix. So this is allowing me to not remove any dead cells, not disturb anything at the bottom of the plate. And then I let it incubate with the dyes for about an hour. And then I'll image it on the Celigo. So let's start to show you how to collect the images on the Celigo. Here in the Home tab, we're going to select Create a New Scan. In today's assay, we're going to try the Greiner plate 655090. This is a black wall, clear bottom plate. This is an alphabetical listing of plates. So once you've selected the plate, we'll then type in a plate ID. So I'm giving it a generic one, Annexin 5, PI Hoechst. And then we'll put apoptosis in the front. And then I do like to put in plate descriptions. So this is the 231 cell line with staurosporin. And then click Load Plate. The stage will open up. You put your plate on the stage, and then you'll click OK. And the stage will take the plate into the system and move over to well A1. This screenshot now moves over from the Setup tab over to the Scan tab. And the first thing we'll want to do is select the application. It's about 2/3 the way down. It's called PS Externalization. And then when you open up that application, there's two options. We're going to choose the one that has the 3 channels. So the 3 channels we're going to be using today are the PSE, dead, and total. So we'll just go ahead and start. Each of the channels is automatically defaultly set up with blue and 10,000 exposure. So we'll go ahead and change each of the channels to the appropriate illumination. So PSE is going to be green for FITSE. The dead channel is PI, so that'll be in the red channel. And then the total channel is blue, so the default is already there, so we're all set. We'll work on exposures in a second. So next, we'll go over to the plate map navigator, and we'll select the selection button and then highlight the wells that we want to image today. So you saw our plate map, we're excluding the top and the lower bottom wells. And then we'll navigate with the navigation button to B2 to start setting up the image illumination and focusing. So typically I'll use the snap button instead of the live. So if there's any photo bleaching going on, snap is just taking a quick picture and displaying it, but not leaving the exposure or channel illuminated. So right now at 10,000 is a bit dim. I know the cells are in there, and 10,000 typically is a little too low for my Hoechst staining. You can up the exposure by just typing in a value. And you'll see the intensity I pointed to down below tells you the pixels as you hover your mouse over an object. So we'll use that to help us figure out what is the exposure we're going to use in a minute. But first, I want to set up the focus. So by clicking Register, Focus Setup, and then Register Auto, the system will move the stage up and down in Z and taking snapshots and then evaluating the pixels to see which is providing the best focus contrast for the cells in this fluorescent channel. Once it's finished, it'll stop, and now it'll be using a hardware focus mechanism to focus for the rest of the plate because it knows the thickness of the bottom of the plate is pretty consistent for these film bottoms. So we'll just use that from now on. So now we can, now that the cells are in focus, we can set the illumination. And ideally, you want to have your objects in the image to be in a pixel range between 150 and 90. That's where the default analysis settings should pick up the cells no problem. So we're just going to up it a little bit. See, typically it depends on your cells, how much they take up the Hoechst, your system, but this is looking pretty good. If you go above 100,000, that tends to take the scan a lot longer and time to finish collecting the images. So if you end up going above 100, I would recommend using gain. Gain tends to elevate all of the pixels, including the background if you have dyes that have a background. So for this, we don't have much background. We could use gain, but I'm thinking that 90,000 is probably pretty good for this Hoechst staining. So we'll move on to the next channel. We'll switch over to the dead. And we'll set up the illumination and focus for those channels. So remember, we switched it to red illumination. And you can see there's very few dead cells. This is a control well, but you can see there's a little speck there. And then we'll just go ahead and turn up the exposure a little bit and click snap once we change the value. All right, so it's a little bit more illuminated. You can hover your mouse and see it's not quite, but let's go ahead and get it in focus first before we set the final exposure. So using find focus will actually help find the focus in this image, but it's not going to remember it. But you'll notice the values that are going to be changing just above the button we pushed is going to change to something that you'll see here. It says -6 microns. So that means it's 6 microns above or negative from a Hoechst blue channel. By clicking set offset, it populates the number up here. And so when we're acquiring the whole plate, it will move to collect the red channel 6 microns below the blue image collection. So that means we'll have it in focus. So now we can set the exposure a little bit better. So 30,000 is about typical from my experience. You're going to have different levels of staining. So this cell is very bright and this one's dim. It might have died a while ago, or it might be a blebbing of the cells. So you're going to have to go for an average, kind of hunt the normal population. So then we're going to move over to the PS externalization channel. This is the FITSI stain. Now, I think typically most vendors that sell this Annexin 5 kit, I've always seen background with this reagent. So you're going to see as we turn up the exposure shortly that it's going to have some background. So that's something that we'll work with in a minute. So let's turn up the exposure a little bit. Let's do 20,000. I do believe this is a dye that will photo bleach, so keeping it in live, you'll start to see photo bleaching. So we turned it up to 20,000. We're gonna do a little bit of find focus to help find the system. If you were to try and do this manual, that means you would have to turn on the live camera and then try and manually move those arrows up and down. This find focus helps quickly do it so you don't have too much exposure going on for photo bleaching. So here we're 20 microns above the Hoechst channel focus registration. So we'll click set offset, and this will mean that the green channel will be in focus during our image acquisition. Okay, so we're in a control well. There aren't many cells here, but you can see that we've got a lower exposure. So let's boost it up a little bit. I think I tried 50. Yeah. Okay. So in your control wells, you're going to have some cells going through the apoptosis pathway. It's just natural programmed cell death. But in a control well, you don't see that many. So let's go over to a treated well. And remember, this Annexin 5 is a surface membrane stain, so it's not going to be very distinct like the nuclear stain you'll see with Hoechst and PI. It's going to have some irregular patterns around the cell nuclei. So you'll see it's pretty good. Let's click on a different well that has some treatment in it that will increase the apoptosis. Here, this is more typical of what you're going to see. The cell's going through, and it's the external part of the cell that's actually getting labeled, and the center portion is kind of vacant. So we'll explain how we can analyze this in a second. So that looks really good. The cells are in focus, we have enough signal, and we don't want to go much more in exposure because the background is already up to about 50, and the camera pixel range is from 0 to 255. So I'm happy with this. So we click Start Scan, and the system will image the plate with those parameters. Now in the Analyze tab, this section I've highlighted in red is the identification section, and that's where you pick up the objects according to their pixel intensity to the background. And then the pre-filtering is filtering out those objects that you detected in the section above. So those are the important functions that you're going to need to understand. And you can switch between channels. So you'll have to set up the parameters for each of those 3 channels. So by clicking on that, you'll notice that when I change the identification one, the pre-filtering automatically switches over to the same one. So let's get started. So let's select a well on the plate map, and we'll display all 3 channels for one of the images in that well area. Remember, the system takes 16 images per channel, and right now in the Analyze tab, we're only displaying one of the 16. So typically I'll use, I'll typically go from the top down you'll see the order of operations 1, 2, 3. I'll start with the well mask, and then I'll move my way down. So the well mask is applied once, and it's applied to all 3 channels. So we'll just turn it on with this checkbox, and then I want to show you what the well mask is doing. So if we have objects outside the well area, sometimes you have things that fluoresce at the bottom of the plate that is not in the well. This is allowing you to not analyze or identify objects outside the well wall. We artificially draw the well line with the engineering plate specifications that come from the manufacturer. And if I increase the well mask just 102%, you'll see that images with a lot of background, when you cross to that well wall area, can be detected as objects. So this is one way that we can exclude the well wall area from being improperly detecting objects due to that elevated background from that PSE channel. So let's bring it back to 100%. And you'll see the orange line move inside, and you're like, well, there's some cells that I'm missing that are so few in number that it really doesn't matter. The analysis is going to be not affected. It'll be more improved by not having those erroneously detected objects. So let's get back to the center of the well. All right, so you'll see that we have the total channel is typically where I start the nuclei, because I know that the cell nuclei is very identifiable. We'll be able to see all of the cells. And we'll work in the order of the identification section first and then the pre-filtering. So we'll turn off the other channels and keep so this is an artificial coloring of the image. Normally it comes in, the image is actually taken in a black and white image. We artificially color it blue. So blue is hard to see on the black background, so we'll just change that color to white. Turning on the graphic overlay, because we set the exposure properly or within that range, the default application values that are in the identification section should work just great. The only thing that I would change is the separate touching objects. That means clusters of nuclei that are close together can be separated and counted properly. That's pretty much all I do for most of my Hoechst staining, is make sure that the separate touching objects is on. Very simple. And next we can turn on to the dead channel. So we'll change the identification from total to dead. And then we'll turn on the dead channel and graphic overlay and turn off the image display for the total channel and graphic overlay. You'll see that we have some dead cells here. Some are bright, some are dim. This is an ongoing event. So we basically have identified them pretty well with the default settings. Again, if you set up the exposure right with the pixel intensities, the defaults should work well. Now, we've got some cells that are not associated with a nuclei, so that means it's probably debris, and it's pretty small. So we should be able to filter out these little teeny tiny particulates that have been identified in the red channel by the, here's a couple other ones too that are not associated with a white nuclei. So let's try and use or showcase how the pre-filtering section can help you eliminate these small particulates that are not really dead cells. So you'll notice the position values down here. This is an XY position. If you run your mouse over your objects, you can get the value of how wide, or the diameter of your object. It's about 5 microns. And then so if you figure that's an area squared, if you type in 25, then you can see that we'll be able to eliminate the object because of its size. So this is a 1 micron per pixel image. So that's helpful when you have that X and Y position displayed down below. You can use that to your advantage to figure out what size is the object you're looking at. Okay, so I know that I've talked about how to identify the objects and how can filtering remove objects that are not there, but sometimes you'll have stuff that is actually of similar size. Okay, so here we're over in the total channel. We forgot to do that one. So in the total channel, we have an object that is much smaller than a typical nuclei, and it looks like it's probably debris. So we'll exclude this nuclei object as a debris. We'll switch back over to the total channel. and it was similar in size, so we'll give it a 25 as well. Whoops. And so then here we have objects that are of similar size to our dead cells. So this is where pre-filtering can get tricky. So if you start to increase that cell area filtering out, you might lose some cells that are dead. So that's not desirable. So how do we get around that? Especially when you have a lot of objects that are just slightly close to intensity. Well, it's not associated to a nuclei, so we know it's not a dead cell. And here in the PSC or Annexin 5 stained membrane, we have a lot of cellular debris, or it would be like membrane particles left behind as the cell's starting to go through the apoptosis pathway. So you get that membrane blebbing that's really kind of leftover residual from the apoptosis pathway. That becomes a little bit difficult to try and figure out how to segment and exclude objects that are beyond the cell body area. So what do? We have a solution. This particular application is called the master channel application, where total, where the nuclei are detected, is the master channel. So the other two channels, the PSE and the dead channel, have to overlap an object of the nuclei. So here we have yellow outline of the nuclei, and the PSE objects have to touch or overlap the nuclei area to be detected or counted as a cell for the PS indication. So what do? Our objective for the PS channel is to try and do our best to identify the objects according to this pixel intensity and not get too hung up on the extra stuff that's beyond the cell nuclei area. So what I'm doing is just lowering the intensity threshold because it's a very faint cell body stain. And that way the objects are being expanded, or the pixel intensity that are a little bit closer to background, I'm picking them up. I don't want to go down to 1 because then I would be picking up way too much stuff. And then you'll see that the nuclei that are centered around the green stain, now that's overlapping, these two objects overlapping or touching each other will be counted as a PSE positive cell, because the membrane of the cell is probably starting to get that annexin externalization. And here we have the PS object detected, and it's not connected to the nuclei, so therefore it's considered debris, and it will not be showing up in your results. So this is how the master application will be helpful in identifying the proper cells, or the cells that are going through apoptosis, and not just cellular debris. So if you looked at the cell or image in bright field, you'll see that the cells have slightly detached from the plate and are rounded up, but they haven't stained with PI, so they're not completely dead. That's just part of the morphological change that's happening. Okay, so I think we've done a pretty good job of the PSC externalization, but you'll notice sometimes it's just picking up the bright part of the PSE. If you want to expand the area to cover some of the dim parts of the PSE, okay, so here's an example again of a PSE counted. So we won't have to do any filtering out, but what I'd like to do is increase the diameter of the PSE objects. You'll notice on the right portion of the image, you have some bright PSE, but it's got some greenness around it. It's almost like we're missing part of it. If you want to capture that portion, so you can just increase the diameter, and the objects that are detected, it will search out a little bit further in that area for stain that's above background. So that's how you can increase this area of PS externalization when it has a bigger body stain than the nuclei. Okay. That looks pretty good. You can see now we have identified the total nuclei cells, and the PSI or PSE labeled or Annexin 5 labeled cells will be counted as positive. And if they're both stained with PI and Annexin 5, then it'll be double counted, but you'll see a section in the data results for those. All right, so next we'll just want to select the wells for analysis and then click select or start analysis. Okay, so in the results tab, you'll see that we have the plate layout of all the images. I've already gone ahead and analyzed the whole entire plate, but I want to go over the data. On the left-hand column, you'll see the measurements displayed. Here we have PS externalization positive percentage, dead percent, and then PS externalization corrected. So those are the ones that you're most going to be interested in. And then below that, you have the counts. So what is PSE corrected? That's actually subtracting out the double stained PSE plus dead cells. So you can get the early apoptosis before the membrane has been compromised and the PI goes in. So that's how it's being calculated. Here we have the double stained down here in counts. All right, and if you want to have the image, the data displayed on the well thumbnails, you just click on the different data measurements. And I like to use this heat map display because the heat map is according to the numbers that are displayed for those measurements. So you'll see the percent dead as we switch over to that. And then you have the PSE externalization corrected. So the heat map is very helpful to kind of see a global effect of what's going on with your plate. You can see that columns 1 and 2 are controls. And I like to show or present in the percentages because sometimes you may not have plated your cells. So you can see in B5, I have a different number of cells. So I probably might exclude that. But when you have it presented in a percentage, then it becomes normalized. Okay, so let's go ahead and double click on a well and observe some of the high resolution images. All right, so here we have just the PSE on. Let's turn on the other 2 channels. And you'll notice the white is still there. So we can change that color display from white back to blue for our total. And then if you double click on this image, it will zoom in real quick to that very cellular level. So here you can see we have displayed all 3 channels, and we just have the PSE graphic overlay on. And you notice all that extra cellular debris or adherent membrane parts that are left behind have not been counted, and it's only when this PSE has been overlapping a nuclei. And then here in the middle, you have your PSE counted. And then here in the upper right, you have a cell that has double stained with PSE and dead. So here you have another PSE positive only. We'll turn off these graphic overlays, and I just want to move around the well so you can kind of see overall how does this image look, because it's kind of really cool to see how the membrane is being stained with the Annexin 5 FTSE molecule, and it's only on a surface membrane stain. So again, the background on the Annexin 5 reagent can get problematic. So if you're going to try this with a kit that you guys have purchased yourself, I recommend doing a titration of that Annexin 5 reagent so you don't get the background. Here we have a good amount of signal with a little bit of background. But it's looking pretty good. Now this is the columns 5 and 6. This is after 4 hours of treatment with staurosporin. When I was developing this assay, it was challenging to try and figure out what is the right cell drug concentration, time, all of that. So this is why I came up with a time treatment over multiple hours to figure out where is the sweet population where you have a high percentage of PS only versus dead, double stained population. And this was my workaround to try and figure that out. You could change the time course. If you had something that was longer, you could do this over multiple days, but this treatment was only about 5 hours, which is nice. Okay. And also for the fact that we're not washing out the cells, because sometimes these kits ask you to remove all of the media and then come in with the buffers, you have the tendency to move cells around and lose some of your dead cell counts. Here we have a control well that you can see that we're properly detecting the cells, and it looks very similar. There's some cell surface staining going on. Some of these cells are going through their own apoptosis induced. Looks very good. This is an endpoint assay, so you want to, after the hour, 45 minutes to an hour incubation, you do want to read it because the calcium-rich buffer will end up, the cells are not happy on that, so you don't want to wait too long after that incubation time. Okay, let's export this well-level data, and now for the 5.0 software that just was released in January a year ago, we have now you have to select the location where you want to export the data, and also the new feature is that you can export it in either plate-based format or tabular. So sometimes tabular is nice, you can just dump those stuff into GraphPad, but today we're going to export it in a plate-based format, which is the typical what most people are used to. Okay, once it's in a export, we'll open up that CSV file. And here at the top portion of the CSV file, you have all of the information high level about the plate and scan. So you have the plate ID, the description, time, software, application, and then you have the data measurements that we saw in the left-hand column in the plate level layout. Here, the PSE percentage, percent dead, percent corrected, PSE. Those are the ones you're going to want to end up graphing. Now, if you go down a little bit further, you'll see that there are the raw counts for each of the wells. So here's the PSE count, and then you have the dead count, and then you have the total count. So that comes from the graphic overlays. But then we have a little bit section down here. This is where you have double scored PSE and PI dead count. This is your double positive stain. And that's how we subtract those values out of the PSE to give your PSE corrected percentage. Further down, you have all the intensities for each of the channels, for each of the objects in the channels. But you'll be interested mostly in the percentages up here at the top. All right, so let's go ahead and show you graphs of the data to showcase the time of drug addition and the output of PSE positive cells. Here we have the Annexin 5 only, so this would be subtracting out any of the dead cells. Here we have, this is actually the Annexin 5 stained PSE counts over 5 hours, and then you have the dead population. So this is where you can use this type of plate layout and application analysis to showcase time of apoptosis. In the image down below here, you'll see with the first image, I've pointing to an object that's detected as early apoptotic, meaning it hasn't taken up any PI. And then in the middle image, I've pointed out an object that has both PI staining and PSE to showcase the two different cell counts. All right, so this is basically what we've covered today. We've shown or talked about the concept of the assay and how to do a time course drug treatment, and then how to stain your plate without trypsinizing or washing your cells, and then how to acquire the images, do the analysis, and review the data. So like I said before, there's a lot of kits available in the market that are designed mostly for flow. So we are currently in the process of working on our own reagent to release with this type of assay. So if you guys are interested in trying it out with our recipe of the volumes that I've determined, please contact us at support@nexlum.com. Otherwise, I recommend you try and titrate out your reagents to figure out what is the appropriate concentrations. Thank you, and we can open it up for questions now.
Thanks, Sarah. That was a wonderful presentation. As Sarah just mentioned, we are opening up this time to answer any questions that our attendees have for us today. As a reminder, everyone is muted, so we are unable to hear you, but please type your questions into the questions bar, and I will read any and all questions out to Sarah so we can begin the Q&A session. I'll give everybody a minute or so to type those in. While we're waiting to see if we get any questions that come through, I'd just like to remind all of our attendees that we do encourage everyone to submit topic ideas for future webinars. If there's a specific application you're looking to see, or a specific cell type or reagent, anything at all regarding the Celigo or any of our other Nexlum products, please let us know. We're happy to oblige and see if there's any popular topics that our customers and attendees want to hear. There is a short survey at the end of this webinar where you can type in your suggestions there, or you can email us them at support@nexlum.com. Okay, I'm not seeing any questions come through, so that will conclude our webinar for today. If any of our attendees think of any questions later on that they didn't get a chance to ask right now, feel free to email us at support@nexlum.com. We'll be happy to help in any way we can. Thank you, Sarah, for a wonderful presentation, and all of our attendees and registrants, please anticipate getting an email from us with a link to the recording so you can watch this webinar over again, or you can pass it along to a friend or colleague if you wish to do so. Everyone, have a great day. Thank you so much for joining.